Alrighty, here we go. Now that you have all the knowledge on how to balance our equations, now we're going to talk about classifying our reactions and work you towards actually being able to predict the future and actually figure out what different equations are going to make as products. Okay, there are five major types of reactions. There are combination, decomposition, single replacement, double replacement, and combustion reactions. To combine something means that you are going to put it together. So they are sometimes known as synthesis reactions. Decomposition reactions are known as breaking apart. To decompose means to break it apart. Replace means to switch. So that means in a single replacement, we are going to, if I could spell that'd be good too. It's SWITCH. I'm going to switch one element out with another. Okay, in a double replacement, we are going to switch two things out from one another. And then in a combustion reaction, we are going to have a big old fire. So you're going to see things get very heated, you're going to produce energy, and things are going to get hot. So the way that I like to help you internalize all of these is by talking about relationship. So you'll notice on the first page, we had a whole hashtag relationship goals because a combination is sort of like a marriage, and a marriage is when two become one. A decomposition reaction is like a divorce. Sadly, not all marriages work, and we're going to break them apart. So, combination and decompositions are opposite of one another, just like marriages and divorces are. A single replacement reaction can be an affair, okay, where you have one thing that's going to try to break up a couple. A double replacement reaction is like that TV show Wife Swap, where you have two couples and they're going to swap who they are together with. And a combustion reaction is like an argument. There's lots of fuel being thrown on the fire. You're going to see that you're going to take in a lot of oxygen and you're going to release a lot of CO2 when you exhale, and you're going to make some steam. You're not making liquid water in a fire, you are making gaseous water in a fire. Okay, so we are going to talk about combination reactions first. Okay, so here you go. So here is your combination reaction. It's also called synthesis sometimes if you want to be fancy. To synthesize something means to make something. To combine means to make something. All right, so this is when you have two or more substances that react to form a single substance. Okay, the reactants are normally going to be two elements, two single elements that we marry together. All right. A plus B, like for two general elements, make AB. All right, and that's exactly what we do. So here are some examples. Okay, if you take an element and oxygen, it's going to form an oxide like we saw with ionic bonding. So aluminum and oxygen, don't let the diatomic oxygen throw you off, is Al3 plus and O2 minus. We crisscross and we get Al2O3. And then you balance it at the end in order to make sure that you have the same amount of each thing on each side. So you put a 4 and a 2 and a 3 here, and then you're balanced. Okay, if you have a nonmetal, you usually literally just stick them together. S plus O2 make SO2. P plus O2 makes PO2. If it isn't going to be just stick together, they'll give you some sort of charge after it. So they could give you like a 3 plus here and an O2 in order to make P3 plus and O2 minus come together. That crisscrosses to make P2O3, and then you would go through and balance that out by putting a 3 here, 2 here, and a 4 here. Okay, so it depends. And then if you basically have your two elements, you are just making your ions come together. Okay, these ions are never going away. Mg plus N2, don't let the 2 bother you. Mg2 plus N3 minus, crisscross, makes Mg3N2, and then you balance it out by putting the 3 there. So to review, you have, when you see two elements, A plus B, two elements being added together, determine your charges of the atom. So either review your ion sheet or you'll be given some oxidation number or some charge in Roman numerals to tell you what it is. Make your crisscross neutrally charged product and balance the equation. And again, don't let the diatomic elements throw you off. Okay, they just come in pairs. You don't always have to use all of them. All right, so here are some great examples for you, and we'll work through these. So we have Al plus F2. Aluminum makes a 3 plus. F makes a 1 minus. So when I crisscross them, I get AlF3. Don't just stick these together, okay? And then what you do is you balance them out by putting a 2 here, a 3 here, and a 2 here. And now we are balanced. Okay, next up we have Mg plus S8. Sometimes sulfur makes these little 8 clusters here. Mg is in column 2, so that's a 2 plus. Sulfur is in 16, so that is a 2 minus. So that makes MgS. Okay, 2 plus cancels out a 2 minus. And then you need to balance it out. I need 8 sulfurs over here and 8 magnesiums there. All right, next we have potassium and oxygen. Don't let the words fool you. You have to make your formulas. K, and don't forget about Brinkelhoff, your diatomic elements. Diatomic elements are Br, In, Cl, HO, and F. Okay, so make your ions, K plus, O2 minus, crisscross, and we get K2O. Is that balanced? Nope. I need a 2 here and a 4 there to balance that out. Okay, what about silver and chlorine? Ag plus I. Anybody diatomic? I. And then we're going to write our ions. So that's going to be Ag making a 1 plus, I making a 1 minus, and I form AgI. And then when I balance that out, I put a 2 in front of the Ag and a 2 in front of the AgI to balance everybody out. And lastly, we have our iron and sulfur. Fe plus S. Okay, it's telling me iron is making a 3 plus. That's what it meant by that oxidation number. So I have Fe 3 plus, sulfur's sulfide, so that's S2 minus, crisscross, I get Fe2S3, and then balance it out. So we need a 2 there and a 3 there to balance. If you can't read my handwriting, here are all of the answers for you. But again, follow the ions. Ions, ions, ions. Okay, so we have Al3 plus, F minus, making AlF3, and then balance accordingly. Mg2 plus and S2 minus, making MgS, and balance accordingly. If you are given a word, make sure you write down your formulas, be mindful of diatomics, make your ions, and make your formulas, and then balance. Silver and chlorine, again, Ag plus, Cl minus, makes AgCl, and balance. And sometimes if you don't know the charge, it'll be provided for you, and you get Fe3 plus and S2 minus to make Fe2S3, and balance accordingly. So that is how you marry your elements in synthesis or combination reactions.